Okay, let's look at a practice problem that explores vectors and components. Just do a couple of them to just get our feet back under us with regard to trigonometry. So this is out of your problem set concept 3B, and we're going to do number 2. It says an object's velocity has magnitude 14 meters per second. So the velocity is 14 meters per second at an angle of 205 degrees with respect to the positive x-axis. What are the horizontal and vertical velocities? All right, so when we're given that velocity, that's the magnitude, the length of the arrow at the direction that it is pointing. So 205 degrees, just to remind ourselves, that Cartesian coordinate system. This is the 250 line, this is the 180 line, so 205 degrees is certainly in the third quadrant, and it's about right there maybe, and we have, oops, 14. And that velocity is at 14 meters per second. All right, so our trigonometry is that sine, cosine, x, and y component. If we always reference the positive x-axis, remember there's multiple ways to do trigonometry in terms of your visualization. I like to do it relative to the positive x-axis because then I know that my vertical component and my horizontal component are sort of what I learned when I first was introduced to trigonometry. So if we always reference the positive x-axis, the horizontal component is the magnitude times the cosine of the angle. And in this case, that's 14 times the cosine of 205, and 14 cosine of 205 is negative 12.7. And of course, we're in velocity, so it's meters per second. Now, it's always important to just double check yourself. Do I expect that to be a large majority of the vector? Well, I'm very low below the horizontal axis, which means I have a good component in that horizontal axis. So 12 is reasonable. Should it be negative? Well, if I look at my picture, it's pointing to the left. And so, yeah, it should be negative. So I have a reasonable answer in that horizontal direction. For the vertical direction, it's the velocity vector magnitude times the sine of the angle. And so we have 14 sine of 205, and we get 14 times the sine of 205, and we get negative 5.9 meters per second. All right, so is that reasonable? Well, it's a small portion of that component, so if we really looked at these components, this is our vertical component, of course, and this is our horizontal component. So it's smaller than the horizontal component. Maybe negative 6 is reasonable, and it's certainly pointing down, so the negative itself is reasonable. So we can always, again, use cosine and sine if I'm referencing the positive x-axis, which this one is doing. But sometimes, for some students, it's easier to sort of look at the triangle that I've drawn. And then we might want to use, let's say, this angle. I'll call that angle alpha. So how would I use that angle in my relationships with sines and cosines if I'm using that interior angle and keeping things in mind? Well, then I'm going to think about magnitudes only and assign direction later. So, first of all, what is alpha? Well, we know that this total is 205. And if I subtract the 180, 205 minus 180 is 25 degrees. So 25 degrees is my alpha. All right, so the horizontal component, well, that's the adjacent. So that is 14 times the cosine, again this is just magnitude, of 25. So 14 cosine of 25 should be 12.7, and indeed it is, but this is a positive value if I plug that into my calculator. And we need to keep in mind that we just looked at magnitude, and then I have to go and say what's the physics tell me. It tells me it's to the left. So the true velocity component is negative. I have to assign that negative value. explicitly if I do not use the angles relative to the positive x-axis. Similarly, the magnitude of the vertical component is 14 sine of 25. And that's going to give me 5.9. Again, a positive value because I'm really only looking at the magnitude. Then I look at the physics. Just positive or negative? Well, the vertical component is pointing down, so I know my true vertical component is 5.9. All right. I don't care which way you do it as long as you're careful, as long as you're showing me that work and how you're defining that angle that you're using. And then keep in mind, you are responsible for thinking, all right, does the physics match my answer? And if it doesn't, how come? And in this case, it makes perfect sense why it doesn't. And then we have to define that direction. So direction is important in physics. Just keep that in mind depending on what angle you use.